This is the first event that we're holding here in Shinagawa in Spaces. And fitting that we're going to be talking about space. So, space with spaces. And my name is Majid, or you can call me Maj. I will be your host tonight for this talk. So I'm with InnoHyve, as you might know. So we've been doing events every 2 weeks pretty consistently for a few weeks now, a few months now actually. Seeing some familiar faces, some new faces. Thank you all for coming, and I hope you enjoy tonight's talk. And for tonight's talk, we have 4 really awesome speakers, and I will let them introduce themselves one by one, starting with Aron on my left.
Hello, I'm Aron. I'm originally Austrian, Europe, and I'm in Japan since 4 years. I created a company called Orbspace, Taguchi heißen, and we are fundraising to make a tiny rocket, actually a tiny main rocket. And yeah, from where I'm coming from is I've been doing rockets all my life. I've been studying in Austria, and then I went to the ESA, 2 years in Japan for JAXA, and then I worked for the Aron rocket development program.
Hi everyone, my name is Janelle Wellons. I am born in the United States, grew up in New Jersey, and went to school at MIT and got my bachelor's in aerospace engineering. After that, I went to California to work for the NASA Jet Propulsion Laboratory, where I worked as a mission operations engineer on projects at the Earth, the Moon, and Saturn. And then this man brought me to Japan to come work for a startup called iSpace, where now I'm working on lunar missions and serve as a flight director and senior mission operations engineer as well. And I've been here for 2 years now, a little over 2 years.
Good evening, everyone. My name is Yuske Taguchi. I'm Japanese, and I work as an APAC sales manager for a company called Axiom Space. Until recently, I was the only one in Japan for Axiom, but in April, this big guy came, and we hit the news. So you might have heard about us recently, but the former JAXA astronaut Koichi Wakata joined us. So I have a very cool colleague there. But Axiom Space, we are providing various services for human spaceflight, starting with launches to the International Space Station, and you can stay up to 2 weeks there and do science experiments, technology demonstrations, even maybe shoot commercials. And we are also developing and building the world's first commercial space station. We're hopefully launching our first module or room to connect it. We've been awarded rights from NASA to build our station connected to the existing International Space Station. And hopefully we'll be launching our first room, or we call them modules, in 2026, so just 2 years from this. And we also won an award from NASA to develop the next generation lunar spacesuits. So there's this project called Artemis, where NASA will be mainly operated and run by NASA to return to the moon and have a permanent presence on the moon. And the people going there on the moon will be actually wearing the spacesuits that we are developing.
Hey everyone, I'm Marc. I'm from Germany. I studied computer science, and now I'm in a European double degree for autonomous systems based in Stockholm and Helsinki. I'm currently writing my master thesis at Asteroid Mining Corporation in cooperation with Tohoku University and the Space Robotics Lab under Professor Katsuya Yoshida, who might be a name to some of you. And Asteroid Mining Corporation is a UK-based company. I'm an associate there and writing my master thesis, and we're working on a 6-legged hexapod robotics platform, which in the future hopefully is going to be used to explore asteroids and exploit asteroids. But for now, we're also focusing on terrestrial applications, for example, inspection.
Awesome. Thanks so much for introducing yourselves. Can I get a quick round of applause? Thank you. All right. So I wanted to start off with maybe a little bit of a philosophical question, which is, why go into space in the first place, right? Like, what is the benefit for humans to go into space? Is there kind of a benefit for us living here on, terra firma? What do you think? Why go into space? Who wants to take this? Janelle, you first.
I'll take one perspective. I think people underestimate the incredibly cool technologies that come out of space. You may have heard of some of them, like Velcro, prosthetic arms. What else can I think of? Instagram filters, believe it or not. These are all things that trickle down from technology that we developed because we were trying to face challenges that we see in space. I think of it this way, it's the final frontier. We call it that for a reason. It's challenging, it's not easy. So it's going to push our brains to another level. And the example I like to give comes from this project called Galileo. It launched a year after I was born in 1995 on a journey to Jupiter. And it was there to do an ambitious science mission. So it required this giant antenna on the top, a high gain antenna. Any science mission needs one of these, and relied on this antenna to send all of the data back to Earth. Well, it gets to Jupiter and they deploy the antenna and it gets stuck. Think of this antenna like an umbrella and it only opens part of the web. Now your mission goal is sending all that data back. You're not going to reach it anymore. Only a trickle of data versus all of this stuff you had promised before. So what did the engineers do? Do you think they gave up, went home? That's the opposite of the engineering spirit. Instead, they found a way. And the way they found was they invented data compression in a way that was going to get them the science data they promised. And so, I don't know, you're as old as me or older, you know about USBs and zip files. This was a product of them coming up with a solution to a problem like this. So maybe we would have got the technology at some point, but this challenge definitely got us there a lot sooner.
Awesome. Anyone else want to listen?
I would like to give it a different spin. For me, there's two types of space. One is the traditional governmental space, and one is private space. The question we are asking for me is the governmental space perspective, because it's taxpayers' money. Why should taxpayers' money be spent for space? How does private space come? And the private space is actually quite simple. We go up a mountain because it's there. So the question is actually to you, not would you want that your government spends money for space? Do you want to go to space? Because if you want to go to space, you're gonna make it. And that's happening right now. And so that's my take of the question is, if we want to make space happen, if we think that's the future in society is what everybody thinks to be the future, then it's gonna be that. Now everybody thinks space is the future, it's gonna be the future. I'm believing that that's mine.
Makes sense. And like kind of segueing into that, yeah, perhaps Yuske, you have a comment.
Yeah.
Please go ahead.
If I can this too, this is one thing that I want people to understand. There is no market in space yet. I mean, I really want people to understand that, people are building rockets, satellites, but it's not to go to space. The destination is not space. It's because you want to bring you just want to use space as a means to bring benefits back down to the planet. I mean, without that, why do you want to spend money in space where there's no market, there's no people, there's nothing there? So when you do want to do something in space, you have to keep in mind that how will this technology, how will the benefits from this project benefit people back on Earth, on everyday lives of people living on Earth? So that's a sort of a mindset that you need to have when you're trying to do something in space.
Awesome. So maybe we're rewinding a little bit, right? So we talked a little bit about, in general, why going to space, right? So for each of you, maybe you can all answer this, right? Maybe starting with Mark this time. What kind of, for you personally, why did you get into space, right? Or like what started your journey, and kind of how do you find yourself now, working at an asteroid mining company?
Yeah, so as a kid, I had this game where you were building rockets, and then I took a break for like 20 years, and I started studying computer science because I wanted to understand AI, and I believed in automation. The automation can like help humanity. And end of day, when you start going into automation, you start thinking about resources. Also, the NASA We're Going commercial in 2019, I think, was very inspiring. So I got like a K-Space, and I want to do automation, and then suddenly there was this documentation about a company called Asteroid Mining Corporation. And I was like, okay, that's pretty cool, because if we have all of these resources, we can maybe use those to help humanity create a degree of automation that no one needs to work, and everything is so cheap and so affordable that you really live in a world of abundance. But for that and for other things like nowadays hydrogen energy transition, you need a lot of resources. So yeah, and then I applied, funnily enough, to an internship for this very company 4 years later, and that's how I ended up in asteroid mining.
Awesome. Yuske.
Well, as a child, the first exposure I got to space was like Gundam and Star Wars. So it was just came very naturally. And when I was 4, my family moved to the US, and I was there for 10 years, and that was from 1980 to 1990, which was the golden age of the space shuttle. So, you know, every time you turn the TV on, it's about astronauts in space doing something there. So, all the boys of the same age in the US, when they grew up, they either wanted to be the president or an astronaut. So I just fell into the same category. I just wanted to go to space. And luckily, I had a chance when I was in my PhD course. I had an opportunity to meet Soichi Noguchi, one of the JAXA astronauts. It was the first time I was able to speak, to just have a friendly conversation with an astronaut. And it really changed my perspective that, you know, until then, I always thought that astronauts were like idols, were like just great people, you know, far beyond my reach. But, you know, talking to them, I was like, you know what? This dude's just another person. Having that perspective is really important because, I asked about how to apply to become an astronaut. I found out that if I got my PhD, I can apply. So all of a sudden, what I thought was just a dream became a reality. So that perspective just really changed everything in me. And ever since I wanted to go to space, maybe become an astronaut, and reach the stars myself.
I love that all these stories are, I feel, going to be really, really inspiring and kind of feel good, right? Janelle?
I hope so.
No pressure.
I feel like I have a lot of connection with your story, actually. I would consider my path to space to definitely not be straight. I didn't even know what MIT was until a year before I applied because my mom said this pamphlet in the mail was from a good school, you need to look at it. So I was not one of those kids who grew up thinking, one day I'm going to be an astronaut. Because of course every kid knows what an astronaut is. You read any book that says, what do you want to be when you grow up? And it's an option with the fireman and the teacher and everything else. But honestly, if you said you wanted to be an astronaut, you kind of sound a little crazy. It's like, oh, that's cute. So I got to MIT and I'm there and I'm thinking to myself that I'm going to become a theoretical mathematician because I just love math that much. Just lock me in a room so I can solve these unsolvable theorems. And then someone talked sense into me and said, you got to do something practical. I said, okay, took their advice, looked at the course listings. I'm at MIT, it's an engineering school, and I see aerospace engineering and it's got space in the name. And I'm like, oh, I could give this one a try. And I'm in class on the first day, my professor's going over the syllabus, and you're gonna learn this and that. And he casually just drops, so yeah, and I'm the astronaut that was helping to fix the Hubble telescope. I looked around at these people like, do you know who this man is? We're in the same room as an astronaut, just like you. Suddenly this thing that was up here became real life. So I took advantage of that opportunity. And ever since then, it was more not a question of why, but why not? And that's what kept me on this path to space.
Awesome. Aron?
Actually, a difficult question because I don't remember so clearly. But somehow it seems I always wanted to do something in space. For instance, I remember when I was a little child, we got a refrigerator. There was a big cardboard box around it. and I made a space capsule out of it. And so anyway, I have to say I'm a mechanical engineer, and I'm one of the worst types. I'm a really gearhead. So when I studied, there was only three things which I was interested in: cars, airplanes, and space, rockets. And so I started studying, and I just tried to keep going the space path. And okay, if that doesn't work, I will become an aircraft engineer. If that doesn't work, I will become a car engineer. But it worked, and I never kind of was knocked out. So I applied for the ESA program. So in the end, I think I'm extremely lucky. There's so many people want to work in space, and so few can actually really get in there. But that's what I want to change, and that's, I think it's going to change now. The industry is so tiny. It's almost embarrassing, especially in Europe, not in the US, but in Europe it's embarrassing how little money we actually spend for space development. People think it's a lot, but actually not. If you look just at one car company, how much they spend for one engine development, just one next generation, it's much, much more. A single company spends on a new diesel engine more than the entire space program in Europe. The point is that actually that also means the progress in space technology was really slow in Europe, because simply there was never so really much money. That's really what is changing now. It's actually a lot of venture capital going into space development companies. That's a huge opportunity, and I really hope that will change. So it was a very long answer, but I was always thinking to become a rocket engineer.
Which you need to do, right? You need to become a rocket engineer. Awesome. Yeah, thanks for sharing all of your stories. Very inspirational, especially because, so for me, MIT was my dream school and I couldn't make it. So, huge respect to you, because it's an amazing school, right? Awesome. So in terms of, I think Aron, you touched a little bit on the state of Europe, right? What do you all see is kind of the difference in the space industry here in Japan versus maybe other places that you've worked? For example, you worked for NASA, right? And Mark, you worked in Europe, or you've seen it in Europe, right? Or you can speak to it at least. So, yeah, how does the space industry in Japan, in your eyes, differ from elsewhere in the world?
Okay, I can start. I'm going to take it from the perspective of just your personal experience in the workplace, and maybe you guys can speak to other perspectives. So, yeah, I was working at NASA, but I don't think this part of it is special to NASA at all. I think it's special to American space companies. So you come over here to Japan, and it took me a while to realize this, but I quit my job for NASA to come to a startup in Tokyo doing space. And a lot of thought went into that decision. There were pros and there were cons, but a pro that I had never considered before was the fact that I was going to be working in an extremely diverse environment. That's not even possible in America due to the restrictions of ITAR and EAR. When I think back, my teams were always American, mostly because they had to be, and especially in mission operations versus like in the science world of things. Now I'm in an environment, which don't quote me, I think I heard a number like 40% of iSpace being international, and I had never experienced that before in my life. And now I'm on a team working with people from Spain, from Belgium, Brazil. We have coworkers from Hong Kong, Thailand, Israel. I mean, this is unimaginable at an aerospace company in the States. And so to me, I think Japan should really lean into that, because being able to tap into that diverse set of experiences and worldwide opinions really brings something special to the team.
Yeah, so I also talked with Aron actually about this before, and I think what I'm seeing, one of the big differences is Japan is more ambitious overall. Like the projects that are born here are overall more ambitious compared to ESA. We have a evolving, I would say in Europe it's getting better, we have an evolving ecosystem. I mean, I've been in the Nordics, Sweden, Finland, they're both trying to do more things, but it's still very focused on specific aspects. So it's like satellites, smaller satellites downstream. You have some people in Germany and in France who are trying to build more rockets, but that's also like smaller payloads. I think Aron said it, like trying to raise money for like rocket development, for big ambitious rocket development is very, very hard. That's always a topic also in German space media, that we have 2 or 3 startups, but they're not getting supported, and then ESA is saying, no, 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 we have Ariane. There's like kind of also this monopolistic view, monopolistic position of like one player that like kind of hinders the financial support that you get. And then overall in Europe, that's also compared to the US and compared to Japan, the VC game is just way different. Different seed rounds, different funding rounds, of all the money is just not invested in that amount in that area.
Makes sense. And maybe kind of on that note, like, you know, how do you all see that, you know, space companies make money? Right? So from my standpoint, I'm kind of clueless. I'm like wondering, okay, you're spending all this money and sending rockets into space. Seems kind of expensive, right? Talk a little bit about VC funding, especially for startups, but I feel like that's more for the initial capital, right? So longer term, what are the business models? How do these companies make money? Maybe we can start with Aron, and then Yuske, I'll let you have the last word on that one, maybe.
It's a question how we make
Yeah.
money. That's a very different.
How do you make money?
Yes, yes. Okay. Yeah, that's actually one of the biggest questions for me as well. Okay, I think we really have to distinguish again, which I said before, the government market and the private market. Companies make good money with government market, right? I mean, Axiom is one of the really best examples. It's how NASA converted their space system to really try to foster startup companies and give companies who are very capable the possibility to renew the system from inside, from a more organizational point of view. It's not maybe so much technologies also, but especially how to make it cheaper. That's one thing, it's government market. Then there's a private market, and I think what we forget is this really huge number of small satellite companies who are developing satellites, deploying hundreds of satellites, and some of them really make money. The challenge or the opportunity now is that really many venture capital companies see the potential and give a lot of money. But the challenge will be to really make profit. How I personally see it is that I think people want to go to space. And I think they will pay for going to space. And in my case, Orbspace, we're developing a suborbital rocket. So it's quite similar to what Virgin Galactic has been doing, what Blue Origin is doing. I think it can be done cheaper. And it can be done more reliable if we apply existing technologies and so on. I'm not going to fall into my pitch, but I think it's possible. And I think it's possible to make money.
So let's say I wanted to take a trip into space, right? How rich would I have to be?
That I can make.
Oh,
Well, park it up. And to give you an answer to Maj, your question, you know, we do sell seats, flights to the ISS. You could stay for approximately 2 weeks. And the cost for a seat is $65 million US.
Anybody want to sponsor it? No?
Approximately.
CEO is shaking his head. That's a lot.
It's a huge amount of money.
Yes.
But to tell you the truth, most of it is just going to SpaceX because they are the only sole provider for human spaceflight in the Western world. Yeah. So they get to decide how much they charge. So unfortunately, there is not there's no competition yet. So it's what they want to charge.
Makes sense. And what's your take on kind of, you know, how space companies are going to be making money?
Well, actually, Aron, brought up a very good point because there is government money and there is private money. And from the government side perspective, if you can provide capabilities that the government sees that they need as a country, that you can definitely get money from that. For example, developing companies, countries like maybe, Southeast Asian countries that don't have a space agency. The first capabilities that they'll be looking for is basically communications, Earth observations, and of course you need an antenna, ground stations to communicate with those satellites. These are capabilities, and you need to launch capabilities to send satellites to space. These capabilities, every country in the world will be looking for them. And as more and more of this gets related to national security purposes, it's going to be a capability that each country needs on their own. because they can't just rely on someone else to provide it for them. And on the private side, just like I mentioned earlier, you have to come up with a business that brings the benefits of space back to Earth. And our company, we're building a space station. It's completely space. We're sending people to space. I mean, like, really? That's gonna bring things down to Earth. Actually, that's a very good point that we really have to think about. And we have done concept studies, market research, and we have determined that this will be a business. That's why we will be a station that costs trillions of dollars to make. And in the short term, we've defined two markets that have probably come. And we are currently already doing some technology demonstrations for a data center in space. And this becomes very viable because of the limitations of communications between space to ground. People may not notice, but we're using radar antennas, which is electromagnetic waves, radio waves. And that the amount of data that you can send from space to ground on radio waves is very, very limited. And because the Earth has an atmosphere, it works as a protection to harbor life on this planet. And because of that, the electromagnetic waves that can carry lots of information is actually blocked because it has lots of energy and damages life forms. So with that limitation, it makes sense to have processing capabilities and storage capabilities in space, so you can process lots of the information and just send down the really necessary information, the results, back to Earth. And another thing, market that we see will be coming shortly, sooner or later in the future, is in-space manufacturing. Because in space there is a microgravity environment, there are many things that happen only in that environment. For example, cells, really at the cells level. When you grow crystals in space, they form very perfect shape because there's nothing that pulls it down to one direction. So with this capability, you're able to, for example, grow crystals that form better semiconductor materials. So it raises the efficiency to grow the crystal exponentially. So if the transportation fees become cheap enough, it'll be viable to send materials up to space, make advanced materials, new medications, even 3D print organs in space, bring it back down to Earth and sell them. Because people will pay, especially if they have an organ transplant.
Yeah, I would also add to that. You both kind of touched upon it, but like this whole, we're building things for very extreme environments, right? We're building things that need to be radioactive hardened, that need to deal, for example, with dust on the moon, or with, in general, very tough conditions in terms of how they're getting energy, because if you're depending on where you're on the moon, you have 14 days of night, so you don't have any sun, so you need to develop technology that can sustain itself for long enough to do very complex tasks without a lot of energy. So building for these extreme environments means that this technology will be also very capable of being used on Earth. And that is a business model saying, we call this dual use technology in the end of the day. It's like, I'll also call it dual use technology, that we can use something that we built for space on Earth for a different application and then generate money on that to build up the larger goals and fulfill the larger goals we want to have in space, that eventually will also generate revenue in space itself.
Makes sense. So basically, we're trying to do cutting edge things in space that potentially will have applications back on Earth as well, right? Awesome. Now, I heard from Yuske a little bit about, okay, we're building a space station. I've also heard that there is some work on a lunar base. Who wants to talk about that? So what's that all about? What's going on with the lunar base? Janelle was like, she really wants to.
I think the lunar base is like the shared vision. I don't think it's just one specific player, but clearly NASA had started the Artemis mission with this idea 2040s, we're gonna have the sustained, well, even before that, actually, I mean, I think there's something that astronauts, but 2028, is that right?
Hopefully.
Holy. Yeah, exactly. And so this concept of this sustained presence makes you wonder, what do you need for a lunar base to be viable? I mean, I remember back when I was in school, I was studying concepts of a lunar greenhouse in Italy, actually, thinking how far-fetched it was, but also how complex it was. Because here I am, an aerospace engineer, who also now has to consider things like nutrition and what do people actually want to eat long-term. You gotta keep them alive, but you also have to keep them happy because they can't just keep coming back because they don't like being there. So it's not just a lunar base functionally, it's a lunar base that can sustain continued life, which means people have to want to stay there. And it becomes really interesting because now you're thinking, this is not just the job for someone like me who works on space robots. It's now also the job of people who are thinking of agriculture, of urban planning, who know how to make transportation vehicles from point A to point B. Now we're all talking about in this extreme environment, so you're gonna have to think a little differently about it. But now we have schools that are graduating space lawyers to be thinking about, if we are going to go, then someone should probably be thinking about how are we going to keep order and law, especially internationally, if we're all trying to build on the moon at the same time. So I think that the opportunities are endless, and this idea of the 2040s being something that's possible, I'm not gonna say it's far-fetched, because there have been naysayers basically for all of space's history. You think you can put something in space? You're crazy. That's literally how the NASA Jet Propulsion Laboratory started. 3 students saying, we wanna try, and they're saying, you know what? You can try, but don't do it here, you're gonna kill someone. Go out in the mountains and try over there. And look how far that took them. So I am very hopeful and optimistic for the future, for sure. And I'm also interested to see how many other people are going to get involved in the game.
And on that note, like to build a base on the moon, I assume a lot of material kind of has to be shipped from Earth into space, right? Aron, do you have any thoughts about like how do we move stuff?
I have 2 thoughts. First, maybe I'm one of the slightly concerned people when it comes to the lunar base. And the question is, why after 50 years, suddenly you want to go back to the moon? What did we do the last 50 years and suddenly we decide there's so great thing to go? The answer is actually very simple. China is going to, and they don't want to let them go first. So we are going to do it harder. So we're going to go there first. The risk is maybe we stop the same way we stopped the Apollo program. And that's not what I want to see. What I want to see in the future is that we have real space activity, private driven, because once private companies are really making profit, they're really going there, they won't stop. So that's my vision, is not government driven. Of course, government is good because private will not do it alone, but somehow try to find a way that we can really settle on the moon and stay there, even if the government might decide one day to not finance anymore. And the risk is there because if you realistically think about the cost, space station costs were enormous. If we go to the moon, it will be manifold. The risk is really there that one Congress or one president decides, okay, now stop it. That's it, because nobody watches anymore. At Apollo 18, I think nobody watched the TV anymore. People lost interest. If people loses interest, government will stop it. So that's what I would like to avoid. So I want to have a vision where we really keep going. And my personal vision is if we can make it private, it will stay.
And if I don't say something, I might get fired because you literally just asked about transportation to the moon, and that is what my company does. So iSpace is making lunar lander systems. So basically spacecraft that can take you from where the rocket drops you off at Earth and then find your way to the moon and land safely on it. And this is not an easy task. I think there may have been 5 or 6 total attempts, like in the past year alone, including my own company. And only one of them was successful. And that success was historic. It was a first for a private company to actually land successfully on the moon and still have communication with Earth. It is not an easy thing to do, but that's why it's so important for us to not just do it once or for only one company be able to figure it out. It has to be quick and it has to be reliable. That's the only way that you can ever make this a reality in the first place. So I'm really happy to be in this like space race right now because I want to be a part of those historic firsts.
Yeah, to that, you talked about materials. So one approach is taking stuff from Earth and putting it up there. But I think this is also where we kind of come into play, obviously, because there are materials up there, not only on asteroids, but also on the moon. So one of the big reasons why we think we can actually at all go to the moon is that I think in 2012, we realized that at the South Pole, we have a lot of water ice. And basically, we figured, okay, we can use that both for fuel and for oxygen. So we can actually, we don't need, if we find a way to like use the resources that are already in space on asteroids or on the moon to like support all of this, we drive the cost down by a lot because we don't need to ship all of that up. We just need to ship a few machines that like start manufacturing and start refining stuff on the lunar surface or on an asteroid, and then we avoid spending, I think it's the rocket people, correct me if I'm wrong, 80% of our fuel going out of the atmosphere. You're already in a low weight environment, moving everything around it gets way more cheaper.
And if I could add to that too. Yeah, I just for reference, sending up to something up to space, it typically costs about $10,000 for a kilogram. And if you want to send something to the moon, it costs about $1 million to send 1 kilogram of things to the moon. So is it, it's just crazy to think about sending materials or resources to the moon. So the concept of using what you have available in that environment, it's called in situ resource utilization, ISRU. Yeah, this concept is growing right now to mine the moon, get resources, use the water. If we can't find ice, maybe collect, there's lots of oxygen there already. It's in the form of this moon sand called regolith. And if we could just collect hydrogen from like the solar wind, then you could just make water from there. So the concept of using the moon as a base is to collect resources to go to Mars. Yeah, because if you want to send a rocket from Earth all the way to Mars, you're gonna have sending a rocket that like 99.9% of the weight is just fuel. So if you're gonna send a person on a rocket to all the way go straight to Mars, you're gonna send a rocket that's weighing like 10,000 tons with one person, something like that. That's just crazy. Yeah. So asteroid mining, finding local resources and using it for other purposes. That technology can be just brought back down to Earth for terrestrial applications.
Yeah, I totally agree. Because it sounds a bit weird. Why would you go to space and bring down some kind of rocks? But actually not, because we don't find them on Earth either. We have to really dig holes. In ocean, it's actually almost more complicated to go deep into the ocean because of the very high pressure than going to space. If we have local space transportation, it's probably cheaper to go to space, pick an asteroid, mine it there, and bring things back to Earth. So I totally believe that. There's one more thing why we want to go to the moon, I think. It's called helium-3. It's a very old story, 50 years or more. It's a kind of isotope which would allow, which actually it's a helium isotope which comes from the sun. And it's extremely energy rich. It's a metal, actually. And you can collect it, and the interesting thing is it's not coming to Earth for some reason, I cannot explain, but it's stored in the soil of the moon. So you can actually process the soil of the moon, and you could do it on the backside, because we never see it. It has this funny characteristics that it always shows us the same size while working on the backside. And we could extract energy, which is actually extremely clean, because it's just helium. And it makes a nuclear reaction with extremely low mass. So it would be a very, very interesting source of energy for Earth. So I totally believe in it.
Awesome. So I think in terms of time, we are getting toward the back half of the talk, right? So wanted to also keep it open to the audience. If you have a question in the audience, we will continue the discussion, of course. But if you have a question, feel free to raise your hand. Maybe one of us will find you and flag you. So yes, I think we have a question back there. So before we'll get to whoever's raising your hand in a second. I actually, speaking of like asteroids and getting material onto the moon, right? I had just kind of a crazy thought in the back of my head, which is, okay, you have asteroids. People have talked about potentially nuking ice caps and things like this, right? If I'm an eccentric billionaire, perhaps by the name of Timon Russ, and I have too much money to burn, right? What's stopping me from kind of just arbitrarily deciding like, okay, the best way to get this material onto the moon is to crash an asteroid into the moon, right? Is somebody going to stop? Is there a government that's going to stop me? Like how far can I get, as the CEO of SpaceX?
Honestly, I think legally the answer is quite simple. There is no international space treaty. I mean, there's three space treaties. One is concerning the return of astronauts. It was made because if Russian astronaut comes down in America, the opposite. Space stations wanted to make sure the astronaut comes back. There's a second one. It's the registration. So any kind of object in space is registered. The third one is liability. Something falls on your head. There's an international space law to regulate it. Other than that, there's no space law. Concerning the moon, there's the Moon Treaty. It was never ratified by anyone. Even space resources is not international space law. So whatever you do on the backside of the moon, in my opinion, I'm not a lawyer, but as far as I could understand, there is no law.
Yeah, I would say that countries, of course, have their own laws and regulations about what you can and can't do and will overlook your work, but that's depending on the country you are developing in, overlooking your work and enforcing the rules that they have placed about keeping this journey to space safe to do. I mean, your question, like, I have had thoughts about this because it's a really legitimate concern, and it really is like the wild, wild west. It's uncharted territory. So what is stopping? If you have enough money, what is stopping you from doing what you wish? Which is why I think that the public interest in space is also really important, because you'd be surprised how much public pressure can change things. If you're canceled, if people start to hate you, if people are booing you, this has an effect. It actually does something. I'm not going to say it's going to stop everyone, but keeping people engaged in the conversation is certainly important, because if they start to forget about it, that's when actors can start to do whatever they want, because who cares?
Well, I have to agree with what Janelle said. I mean, public pressure, pressure from everyone else. I mean, people in the end, they don't want to have warfare, or they don't want to pollute other cosmic bodies like the moon. There's this concept of called terraforming, making another celestial body like the Earth, so it can harbor life. But how, to what extent can you actually really do that? Because you're just damaging the available environment and just making it something very different. That means that there's no Mars anymore. It's just another Earth. Yeah, is that really something that you really want to do? So, yeah, in the end, I think that even if there was someone rich enough to do it, that person would have to do it alone. Yeah, and that is impossible these days. So I don't think, I hope that won't happen.
Yeah, I mean, I think the most important things have to be said. I hope that the checks and balances of the nation states in the world kind of would keep those people in check, because even though we have private companies operating in space soon, everything we do also in space will have implications for the geopolitical situation on Earth. So I would hope that whatever government is doing that is gonna stop that bad actor, because it wouldn't be in their own self-interest. It gets dicey when it starts to get into their own interest.
I would like to put a tiny little different spin on your question. You said throwing an astronaut into the backside of the moon. What about the real problem we have right now? Space debris. So many things in space, so we're getting so crowded. As well as, I think as far as I know, two collisions of 2 or 3 collisions of satellites in orbit. So just, they just crash into each other because they're moving so fast that even if they're so far away, but eventually they crash each other. And the problem is not the 35,000 objects larger than 10 centimeters, already quite a big number. It's actually, if you go down in the size, 1 centimeter is about 1 million. And it's an estimation that actually we do not know, cannot measure from the radars and so on. These small things we cannot trace. The point is, one of the real concerns, and I think where I hope the world will move, is how can we make an international regulation to regulate space debris? That not every rich person can just put as many satellites in orbit as he wants, but there is some international consciousness. That would be my wish for the future, but I don't have the answer.
Makes sense. Yeah, I'm sorry to Elon Musk. Yeah, somebody in the audience, I'm not sure. Raise it.
Thank you for your talk. So 80 years ago, right after World War, people were saying that we will lead to unlimited energy with nuclear fusion in the next 30 years. And then it has been 80 years and we still don't have nuclear fusion. So my question is, what is the state of space technology? I know that there are a lot of minor, really a lot of good progresses, Velcro, good technology. I have it right on my body today. But I want to ask what is the timeline for human can have an unlimited resource that I can build my toilet bowl with pure gold? That kind of level of significant human civilization leap.
Yeah, so we're working on that. Very hard, but giving a timeline is always difficult. Like for the lunar base, you could say, okay, we built I think the space station took around 10 to 15 years to build. It's like the moon is still kind of close and has a decent amount of resources. If we're talking unlimited, there have been studies on asteroids that if you mine 2 or 3, if you would release all of the materials into the market, if you would get them back to Earth, you would lose money because you would basically the price would fall so heavily because the supply is so high that if you would release everything at once, you would make your own profit smaller. The problem is that going to an asteroid or going to Mars is super hard. It's a moving object. You need to go there, but you also need to bring everything back. There's this whole supply chain in terms of mining what we has on Earth has to be abstracted away to space. What I can say is, I think the Americans, Astroforge, they estimate that they can bring back a ton of material by the end of 2030. By the end of this decade. Other companies are a bit more conservative. I think my personal opinion is probably that this will become a large-scale industry when I'm retired, so in 40 years. But the more optimistic people are saying mid-2030s, but that depends on so many things. Because one of the issues is actually that you don't have a lot of chances to test your technology. So I think we have a launch window to the Mars where it's where a rocket goes there in reasonable time, in 6 months, every 2 years. With asteroids, it's similar. We have a few more chances, but just trying. I think it's telling that we only had 3 missions that returned samples that overall now are in less than 1 kilogram. And even if we throw a lot of money on there, we only have so many chances to test that. So that's why it's going to take. I believe it's going to take us a bit longer, probably until I'm retired.
Now, if I can provide an answer, a direct answer to your question, actually, there's always been this concept of having solar power cells in space. Because actually, just like I mentioned before, many of the high energy waves that come from the sun is actually, we are protected on the Earth, so it doesn't reach us. But if you could have access to those waves in space, it actually generates a tremendous amount of power. And you could collect a year worth of the energy that the whole planet uses in about a few hours if you have solar power cells in space. So it's very, very efficient. But the problem is that there is no way to transfer energy. That's the biggest problem that we have. And also, food for thought. If you could develop this technology, you'll win the Nobel Prize. I assure you that, because this is one of the biggest problems that we're facing. I mean, there's lots of the energy is just so abundant in space, but it's just that we just can't bring it back down to Earth. But it is there. It's just that there's no way to transfer.
So I think we're a little bit past 8, so we'll take 2 more questions from the audience. Unfortunately, I think it's one, and then Paul, I think you had your hand up in the back there, right? If you have more questions, there will be a networking session afterwards, so you can talk to the speakers in person, one-on-one, 1-on-5, 5-on-1. Yes, so you had a question back there.
Right? Okay. Thanks for your insight so far. So humanity is facing climate change challenge. In the context of limited resources on Earth, do you think space exploration and innovation is the best way to overcome this challenge so far?
Climate change.
Can you repeat that? Can you repeat the question?
The question? So humanity is facing climate change challenge, like global warming and everything. That is getting faster and faster. In the context of limited resources, is space exploration and innovation the fastest way and best way, in your opinion, to overcome this challenge?
Of course, some problems, absolutely. So when I was working at NASA, I mean, my eyes were all for like the Mars 2020, Curiosity rover, Cassini mission to Saturn. But I had no idea that NASA JPL was about 1/3 of their projects were Earth observing missions. They were Earth focused. And a lot of these missions are looking at trends of how our Earth is changing over time. And right before I left, I was working on this project called the Multi-Angle Imager for Aerosols, or MAIA for short. And the idea of this project, it was actually the first of its kind to not just be funded to build this scientific instrument, but also to fund an epidemiology study afterwards from the data that it collected. So what was it looking at? This was a mission that is going to be flying on an Earth observing satellite, looking down at different targeted cities chosen by scientists every day at the same time to measure particulate matter in the air. Small particles that we breathe that cause health issues. Environmental issues are in the top 5 causes for human death globally. And the thing is, the only way to measure this on Earth is to have one of these monitors near your house. And they have to be maintained. People literally have to go out to this location and change out the memory cards by hand in order to get this done. You put this technology in space, and now you have a guaranteed 5-year study at the same time, data collection going on for it can, and all NASA missions start off saying, oh, it's a 2-year mission. Then it ends up being a 20-year mission because it never dies. So I'm really interested in when this launches, I think maybe sometime next year, because it's going to have a direct impact on human beings, not because it's going to develop the policy, but it's going to inform what policy different places around the world should take based off of the data it gets.
I think the two questions are very connected in your response too, and I would like to connect them. The environmental problem we have today is CO2 emission. It's energy. We have to get our energy from somewhere else. And space is a good place, but solar space energy, actually, for those who are interested, I read an article 2 weeks ago. Really, really excellent discussion about this technology status and how realistic it is. I don't want to go into detail. If you are interested, I can send you the link. Just contact me afterwards. It is very difficult, but I agree beaming down the energy to Earth from space is very difficult, but there might be other things, might be other options. I think you should never say never. If somebody finds a solution, that could be a Nobel Prize and it could be the solution. Yesterday I had been at a presentation and I was really amazed. Somebody showed an image of New York about 100 years ago, and then 20 years later. First image, everything full of coaches and horses. 20 years later, no horses, all cars, all Ford keys. Just 20 years, the world changed completely. Sometimes innovation can be extremely fast. So even if the space development in the last 50 years, at least for the rockets, there was almost no progress. We are building rockets today the same way we built them 50 years ago. Same hydrogen, same rocket engines, everything the same. That doesn't mean that we cannot make a change. It can happen sometimes very fast. And I think it's going to, in the next 20 years, this is going to happen. So I think we will all see this before we retire.
Can you hear me? Okay, good. Nice. So, how about some physical limits on the technical limitations for the space exploration? You mentioned like asteroid mining, right? But to send back from some random asteroid, and let's say the asteroid belt, rocks in the quantity of a small city all the way back to Earth, the energy consumption to get that delta V done, achieved, is that something that is technically feasible from like limitation? Like we haven't had any progress in rockets for the past 70 years, but that's because the rocket equation hasn't changed and it cannot really change because that's just how physics works. So we talked about how things might change in 20 years, but we were talking about flying cars 20 years ago, and we still don't get flying cars. So that's mainly such small ones don't understand cars. Right? Like, how about, aren't we being a bit over optimistic with some of these predictions? Mainly only from the standpoint of it's not entirely feasible energy-wise to do any of these things at scale. Can you make it scale?
Oh, can you repeat the question?
Like
Sure.
physics might not allow these space technologies that we're talking about and planning for, building these companies for, to exist at scale. What is your thought on it?
Okay, so if I can paraphrase, like what are the physical limitations, right? Or,
Yeah,
Yeah.
like
yeah, we're trying to.
yeah, the physics limits our ability to scale this commercially.
Asteroids.
Yeah, so rocket equation is a problem. We're getting kind of back to that's actually one of the biggest challenges. One thing you're trying to do is why a lot of people want to go to the moon first. If you can launch rocket from the moon, you save fuel, so you have more potential there. Another thing is, and I think this kind of applies to everything, to all of the projects we're talking about. When you are on the moon, and if you use in situ research, if you utilize resources there, you solve a lot of problems because, as I said, you need less fuel, you can build from there. And in general, you start what we're doing, I think what all of us are doing end of days, we're working more around the physical limitations, and we try to see where can we build infrastructure to do that. In terms of when we talk specifically about asteroids, we had the DART mission that, for example, altered the path of an asteroid. That's one way how you could, instead of going there, just bring the asteroid closer to you. That brings a whole lot of other problems with it, as we already discussed. So you're trying to, so there are physical, like the short answer is there are physical limitations, and we're trying to figure out if we can work around them. And in terms of asteroids mining, we hope that the unit economics work out so that we can bring back enough material for the cost we're putting in. And by some studies done in the 90s, if we can mine 2 or 3 asteroids, we're going to get a lot of money. So we just kind of hope that, we try to figure out a way to make it possible, basically, around those physical limitations. But they're definitely there and they're a pain in the ass.
I have one more limitation that is definitely something that we can tackle, and it's storage capabilities. How much is for data-driven missions? How much data can you keep on there? And also, this ties into operations, in other words, my job. So honestly, the best way to do these operations is lights out. You don't need a human in the loop. You got artificial intelligence now. We can make it smart enough. It can choose which data is the most interesting or most valuable to keep because you have a limited amount of space to store it on and bandwidth to send it back to Earth. But I always kind of found it funny that when I worked on some NASA projects, especially on the instrument side, that I could compare our storage capabilities to like a PlayStation 4. Like, why are we limited to like 2 terabytes of data? Why not more? And I think that the limitation is being driven by radiation hardened material that can last space. So I'm hoping that material science people can have a way to step in there and give us more equipment that can last longer in that environment.
And then you have like Voyager, which is just
But that's also an energy problem, right? Because then if you go to asteroid belt space, then the efficiency of your solar panel degrades, so then you're going to have to go nuclear for any of your robots and drones to even send any of the data back or store it or anything. And that's another limitation. That's probably not. Final. What are your confidence? How confident are you that the technology is physically achievable, like 20%, 50%, 80%?
sorry, Paul. I'm gonna.
Sure.
But I will ask a question that will hopefully get to that. Yeah. With that said, like, wanted to thank you all for your opinions and thoughts. So what I wanted to leave everyone with, which we'll go around in this direction, right in the panel. So this will end with the mic on Mark. You can answer this question kind of in whichever way you like. But either how do you kind of see the space industry? Like, how do you see it developing over the next 50 years? What's going to kind of be the state of the art, let's say, in 50 years? What are we going to be doing? Or what do you want to see happen in the next 50 years, right? Like Mark, you said, by the time that you retire, right? Like, what do you hope to have seen in terms of the difference between now and 50 years from now? And you can pick a number, not 50 years poetry.
I think the problems of space are not as much physical part, they are cost. You have to get down the cost. If you can get down the cost, you know, like for piston engine cars, since 30 years, people say it's no future. And every year, car companies make them better and better and better. The consumption of cars became so good since 30 years. And so many people say it's no future. It's same for the rocket engine. We can actually just start making it so much better, and there is so much potential. So the point is how to make it cost efficient. How can we make it so we can carry people? And my vision of the future is things got cheap if we produce them in large numbers. Everything which is produced in small numbers can never be cheap, and this is the core problem of space. We have to make it many times. If this happens, and if you can think of markets to achieve that, we can bring down the cost, and we can do this cost loop the other direction. Gets cheaper, more customers, gets cheaper again, we can increase the flights and so on. So this is actually, for rockets, that's the way to go. This is my future, my future vision. And we will fly to space the same way, like aircraft. Just we cannot imagine today, but if it's safe, and if it's affordable, we will have so many flights and nobody will think. And it is sustainable, and it's possible. I mean, rocket is 70% liquid oxygen, because it carries oxygen with it. So if we produce the oxygen with solar panels, it's sustainable. So that's way to go, and that's my vision.
Your vision ties into my vision, because I was going to say accessibility. A place where space is not for the select few that have enough money, but instead can be accessed by many. And this is tied to, it has to be cost affordable. And just looking at it from another perspective, One of the things I do apart from my day job is outreach. I love giving talks to schools and students to let them know that it's possible to have a career like this, because it took me going to college to finally having that thought in my head. But at the same time, I'm speaking to students where it really does seem far-fetched. And I don't want it to be that way. Not everyone has the same opportunity. And if you're in a country where you can't just hop over to America to get a job, then you're limited. And if we make space more accessible and more developing countries are able to access it because the technology is becoming more commonplace, it got cheaper, I really think it's going to make the world a more equal place at the end of the day.
Well, physically and technology-wise, I think it's starting to get more and more difficult to predict what we can see in 20, 30 years in the future, even, well, more if it's 50, because, nowadays, the technology doesn't evolve linearly. It goes exponentially. Because, nowadays, every year you have a new iPhone. It's hard to predict what kind of iPhone we'll have in 10 years from now. So if the technology is evolving in space, it's more difficult. But there is on the mental side of things, there's some hope that I would have, that I really wish this would become a reality in space. Is that right now we do have astronauts living on the ISS, but it's like to extend about a year at the longest. So we still don't have permanent presence in space yet. So we don't have any rules, regulations, or laws defining our activities over space. But because of this, I think that going to space is an opportunity for humanity to start over from zero. So my hope is that we come up with rules and regulations based on the fact that space will be used in peace. I mean, I really hope that this becomes a reality, yeah, but I already see some things going on that prevents that from happening where, for example, the US, even Japan follow that they get to claim the land, whoever goes first. Once you start talking about property, it just evolves into conflict. So, but I hope that we still have enough opportunities to counteract that and evolve as a species as we go into space.
Space pirates. With robot arms. On a less joking note, although I think we're going to have some sort of space piracy eventually, like realistically also what Yuske just said, we're not going to strip off the geopolitical issues that we have on Earth, depending on how well sustained the moon might. I'm pretty sure we're going to have a human presence on the moon if there is a reason for it. If that ever becomes self-sustained, we might actually get humans on the moon that declare independence from Earth, how we had it with the Americas, and the same goes for Mars. If there is resource independence from Earth, that might actually happen. In general, I think what we're going to see is we're going to have a very big ecosystem. So we're going to have supply chains from the moon to the Earth through the satellite belt. I hope we really work on this debris problem, maybe with also thinking about recycling, because that would be also something that could help us on Earth. And I know some people personally who are working on that as well. And yeah, I hope what Yuske said, we have a regulatory I'm pretty sure we're going to have a regulatory framework for these things because people are working on that as well. So I don't know if it's like in 50 or 40 years, but I'm pretty sure these things will happen. If it's exactly in 40 years, who knows, but they will happen. For a very simple reason, with the things that are happening on Earth right now in terms of population, resource demand, we literally have no other choice if we want to avoid a lot of things that are very bad. We need to go. We will be in the long term forced to go.
With that, I think we will wrap it up, I guess, right? So thanks everyone for coming. Yes. What we're going to do is we will have a networking session. So for those of you who came at the beginning, basically just feel free to mingle. Meishi Kokan, right? If you have your business cards, feel free to exchange business cards. Feel free to talk to whoever you want to talk to. There are drinks on that table back there, and then there's lots of food as far as I can tell still on that table back there as well. Please enjoy the rest of your time at the event. And thank you so much for coming. Hope you had a good time. Give us feedback on what we can improve about any aspect of the event, right? In terms of the venue as well, it was new. Thanks to Brian and the Spaces staff for making us feel at home. And with that, thank you.